In this episode of Hot Hardware's 2.5 Geeks, Intel says, you can't stop us now. Next. Welcome back, my brothers and sisters, to yet another fine episode of Hot Hardware's 2.5 Geeks. It's good to see you all again. We are in the Brady Bunch format here today. That was trying to be a Rage Against the Machine reference, lyrical reference in the tease, but I kind of botched it because I'm tired, because we have been raging against the machine for the last couple of days, right, Marco? The brain melt that is Intel Architecture Day.
I haven't stopped for 3 weeks. I think 6 launch articles in 14 days. So yeah, I'm beat up.
Is that all? Oh, come on. You got this. Well, obviously, we are a little bit of a different format today. We have a special guest with us here down in the bottom Brady Bunch window, and that's a guy by the name of David Kanter of Real World Insights. He is an industry friend, an industry veteran. He's been around for a long time. We see him at all the events when we're not tripping around, or when we could trip around on planes pre-COVID, and now we see him on Zoom calls like this. How's it doing? How's it going, Dave? Good to have you with us.
It's a fantastic afternoon. You know, I'm in sunny San Francisco, although I had to pull the blinds down so I don't get washed out. But no, it's been good. And you know, Architecture Day was pretty fun. And I don't know, it's just like there's it's also a kind of intense week for me. I'm on the program committee for Hot Chips, and I'm chairing a couple of the sessions, and so that's next week, so I'm gearing up for that. So it's promising to be a very exciting couple of days.
Nice. You're on the program committee for Hot Chips, so you actually advise Hot Chips on the format and all that good stuff.
Well, the format's mostly set, but you know, we select the papers, and then sort of one of the things that I'm actually super thrilled to be doing is I put together a tutorial. So I kind of came up with the idea that, and for those who don't know, Hot Chips is sort of, I'd say, one of the preeminent sort of chip head conferences. It's, you know, the right combination of sort of a bit of like a lot of architecture, some products, some circuit design, but, you know, not going to blow your head off on any of those. And the tutorial that I put together with a bunch of friends was really for sort of a chip architect. Here's the 101 and 201 about machine learning, right? What does it actually look like as a workload? How do we use it? What are some of the things that are underappreciated? So that's going to be like my Sunday morning. No cartoons for me, just Hot Chips.
No yabba dabba do. Hot Chips it is. All right, cool. Well, that's good. Good stuff. It's certainly, yes, absolutely a in-depth, deep dive kind of conference. And I don't think it's for everybody. It's for the engineering-minded folks out there, and certainly you are one of them. And the industry that we're in, certainly there's a lot of high-powered brain trust that will appreciate that. But there's always some interesting disclosures that do sort of get out there in the mainstream and delight at the consumer level as well as the engineering level. So cool stuff. Well, Dave, welcome to the cast. Thanks for joining us. We called you in today to kick around all the sights and sound of Intel Architecture Day 2021. We'll dive into that shortly. We did have a little bit of something to chew on pre main event, pre the meat of the show with Intel here. But Marco, you said you've been doing a lot of reviewing these days, and we might as well just kick this off real quick and talk about the AMD Radeon. I'm going to drop this into the chat. Let me see if I can do all this stuff. Here we go. There's the comments. Okay. Radeon RX 6600 XT, and I will share the screen. Okay, and by the way, folks, you're going to have to bear with me today because we don't have Chris with us, and he usually drives the knobs and dials, so I am here floundering for your amusement. At any rate, Radeon RX 6600 XT review, AMD RDNA 2 for mainstream gamers. Marco, your quick take analysis of this recent review that you grinded out.
So the first quick take, scroll down just a touch because we have to admire the photography. My God.
Look at the devil.
What a photo.
Yeah.
Unbelievable photo. So not much to say about the 6600 XT that we didn't cover on the last cast. except we finally were able to run independent benchmarks. And the card lands right where AMD said it would. It's a strong performer at 1080p. It generally beats the 3060, gets kind of beat up by the 3060 Ti. But pricing is where all the discussion has been. MSRP 379. There were actually cards available at MSRP, which is somewhat of a miracle. But that MSRP is only $20 below a 3060 Ti, which offers significantly more performance. But you can't buy 3060 Ti's anywhere close to MSRP. So it's a dicey discussion. But if I boil it down to, just the most basic level, strong performer at 1080p. If you're looking for an upgrade, say you have a 10 series GPU or a pre-Polaris Radeon, it's perfectly, a great choice for 1080p gaming at a relatively affordable price. But yeah, if you have the funds to save up a bit and score something in the next tier, much more performance to be had.
Yeah, and it really depends on that MSRP issue fixing itself and becoming a non-issue someday in the future, in our dreams, I think. David, are you a 1080p gamer, or do you game at all these days?
It's funny. I think like a lot of folks, I got into this for gaming. The way I ended up owning Real World Tech is I was building a computer, trying to figure out what to buy and trying to understand why a certain processor was faster than another. And that was like the only site where I got like some people who were explaining what silicon on insulator was and whatnot. So the irony is, that was like, gosh, late 90s, and the quest to discover more about chip architecture and semiconductors has stuck with me, but I actually haven't played games in like 4 to 5 years. At this stage, like I'm big into like making sure I can transcode and then drive multiple monitors, right? Honestly.
Amen. The tools.
Yeah. And, like one of these days, like I sort of have this vision that like when I retire, like I'm just going to go back and be like, oh man, like, I played Skyrim, right? So that was a really fun game.
That was a good time. Yeah. Back in the day.
Before I took an arrow in the knee, and now I can go back and like, get in like all the sequels or, all the games that I've just missed over the last, 5 years, like just save them up for when I'm retired instead of watching like soap operas.
Yeah. The daytime television thing doesn't quite cut it.
That's right.
So you might as well game. So Marco, your general synopsis of this is competitive card in the 1080p gaming space, but on the fringe from an MSRP standpoint, belly up a few more bucks if you can find something in MSRP, maybe for a lot more performance or potentially more performance, right?
Yeah, we could geek out and talk about the 128-bit memory bus and why that's not really an issue because of the infinity cache on the GPU. That was a lot of discussion going on when the launch hit. People were poo-pooing a 128-bit memory interface on a card at this price point, but the performance was there. It was exactly where AMD said it would, and where it would land. And I would have no problem recommending it for anybody looking for a 1080p GPU.
There you go. Well, and by the way, we have a comment from the Peanut Gallery. James Pryor says, "Who's got sodas? Making me thirsty." Hang on. Right there. It's beer 30 now officially here on the East Coast. It is 4:10 p.m., but we've been working all week. So this is a Greater Good Pulp Daddy. Okay. Pulp Daddy, I believe. Yes. Pulp Daddy from Greater Good. I got my koozie on there too. And that is from Greater Good Brewing Company in Worcester, Massachusetts. Wormtown, as it's affectionately called out here in the Boston area. And yes, there you go, James. That's my soda for the day. We occasionally, David, in case you hadn't seen before, we occasionally do a beer intro review, quick review, not sponsored or anything. Chris and I tend to be beer drinkers, and Chris isn't on, so I had to carry the torch today.
Yeah, Fat Boy's got water.
I'm also drinking water. I mean, given a choice, I could do a couple beers, but honestly, if I was going to exclaim the virtues of any particular intoxicant, it would probably be Whistle Pig.
Oh, you like the Whistle Pig. Excellent.
I do like the Whistle Pig. I have, everyone has their sort of like pandemic purchases. Mine was, I like trying new things, and so the Costco wine steward is very familiar with me, and The liquor cabinet is currently full, and so it's like I have to drink something before I put anything in. And I remember my parents were over here, like, David, do you have a problem? And I'm like, no, I don't. And let me tell you how you can figure that out. All those liquor bottles are 80% full. If they're 20% full, then I've got a problem.
Yeah, I don't know how long, frankly, the Whistle Pig would last in my household. That's good. Is that bourbon? I believe it's bourbon. Is it right?
It's a rye.
A rye. Oh, that's okay.
Yeah.
So
I do have a couple of
spicier.
of bourbons. Yeah, exactly. I like to keep it spicy.
Keep it spicy. There you go. All right. Well, let's dive into the main event. Let me share this out, and I'm gonna keep making you guys wait a second or two, a nanosecond or two. Intel architecture.
While you're getting organized, I'm gonna quickly burn through a couple other big things we launched, just so everybody knows the hit.
Go for it. Yeah.
So this past week, actually, over the last few days, in addition to the Radeon 6600 XT launch, we got some hands-on time at Samsung's Galaxy Unpacked, our first, post-pandemic in-person event. We have some videos of all the new Samsung products. We also posted a deep dive review of the Asus smartphone for Snapdragon insiders. Really interesting device. Another one where pricing is kind of the topic of the day. And just yesterday, Google launched the Pixel 5a. We have a deep dive review on that phone up as well.
Okay,
that's out of the way.
There you go. Hang on one second. You're really screwing me up because now I'm fetching links, but it's okay. It's okay. You can torture me.
It's all good.
There's the Samsung Galaxy Z Fold 3, Z Fold, Z Flip 3, and watch. This is the smartphone for Snapdragon insiders. Hitting the links on that. And hey, we got a Pixel 5a review, so we might as well throw that in there too. Pixel 5a, by the way, and before we get to the Intel main event, Pixel 5a, again, no huge surprises from Google with this phone, but for the money, I think it's $449, probably one of the best values in Android phones on the market. Not going to break any benchmark records with that thing. Snapdragon 765G under the hood, killer camera. Water resistant, water and dust resistant, IP68 resistance, and great, just a great set of basic features. 6.34-inch OLED display, only 60 hertz. I don't know if mainstream's going to miss the high refresh rate, but for the money, headphone jack. Really a very balanced phone, I would call it, and a great value. So there you go. Quick little Turbo Pixel 5 review. All right, so. Let's get back to this one again. Intel Architecture Day 21, Alder Lake, Arc, Sapphire Rapids, Ponte Vecchio, all the code names. And I'm going to share this out here. Hang on one second. Still working the knobs and dials. And here we go. So let's settle up to this, David, Marco. There's a lot to unpack. I mean, we got the better part of maybe 3 hours of presentation in turbo mode.
Oh yeah.
Very well done, I would say, by the way. Kudos to Intel for really a good digital venue. I mean, they've really polished things up. Some of the sizzle reel, some of the slick green screen work that they do with some of their execs on stage. Really, really well done, well produced, as a big company like Intel should be capable of. But it's not always easy. I mean, these virtual venues. I mean, you gotta kind of break out and do something to stand out, and they did. But man, this visual right here says it all. I mean, they unpacked a lot of stuff. Let's take it one at a time. Easy for me to say, right? Alder Lake architecture. We'll get into Intel Arc, the GPU architecture. We'll get into Sapphire Rapids for the data center Xeon crowd, and a little bit of Ponte Vecchio for the HPC crowd. Where do we want to start? We want to start with let's start with Alder Lake, and let's talk about this. Marco, I want to get your initial thoughts on it, and then we'll have Dave dive down. I'd like to have Dave dive down on some of the deep technical stuff, but the turbo, very high level, 10,000 foot view, hybrid architecture, big little design, efficient cores, performance cores, and IPC uplift across the architecture, both efficient and performance core versus previous gen architectures like Skylake. And they showed some pretty impressive enhancements, deeper, wider, smarter, as they say, in terms of cache complements and tweaks to the pipeline and fetch and all that good stuff. Scalable client architecture, as you can see here, desktop, mobile, ultra mobile, okay, from 9 watts to 125 watts. So that's the high level. Integrated graphics on all of it, by the way, Tiger Lake class graphics. So it's Intel Xe graphics versus Arc graphics on board these. And, you know, the mobile class graphics probably won't change much in terms of their performance. That's our guess. We haven't seen it. You know, there may be tweaks to clock speed and things like that. Okay, Marco, high level takeaways from you, thoughts, and then we should ask Dave to help us out with some of this deep technical stuff, because the building blocks are what's interesting.
Yep. So high level takeaway, we've been talking about Alder Lake for a very long time. We kind of knew what was coming in terms of product. I think the most interesting tidbit that we got was the I'm already forgetting the name of the thread scheduler. What was the name of the thread scheduler, Dave?
Thread Director.
Thread Director.
Thread Director. So the integrated hardware thread director. So with the hybrid architectures, we saw with Lakefield, that first low power hybrid architecture, some really funky performance and weird behavior in Windows 10, and that led everybody to say, these big little setups with slower cores and higher performance cores may not behave particularly well with Windows, and it was a source of much speculation. But with the disclosures about how closely Intel has been working with Microsoft with the new hardware-based thread scheduler, and how it's going to feed the OS with much more information than just simple CPU states, could change the game. I'm cautiously optimistic in terms of the presentation. Intel did set it up.
Sorry,
no problem. I left Architecture Day more optimistic than I was before.
Yeah.
So I think at the high level, I want to believe Intel's executing here, and this is going to be a strong part. And they said many of the right things, but I think we have to wait and see.
Yeah, let's I would agree. It's always a wait and see, right? It all sounds good, right? The IPC uplift and performance and efficient cores that they claimed certainly all sounds good. Let me see if I can. The screen share thing is always tough. I'm going to try and do this again. Hey, there it is. Yeah. But it's really, the proof is in the pudding for when we actually get our hands on to test these things. But let's talk about this, Dave. There's a couple of interesting architecture aspects that I think kind of stood out to me for Alder Lake. So you've got up to a 16 core instantiation, eight performance core, 8 efficient core, and performance cores have hyper-threading. Efficient cores are single threaded, up to 30 megs of non-inclusive last level cache, L3 cache, and some other interesting enhancements. Like, one of the things that stuck out to me was the 2x larger instruction cache on efficient core, and what that might mean for performance, and some of the performance claims that they made versus Skylake, where an efficient core, the real estate, the silicon real estate of an efficient core, that you can fit 4 of them in a single, and what it takes to map out a single Skylake core in silicon. You can fit 4 efficient cores, but you get about 40% uplift in performance at ISO at similar clock speed versus Skylake, and or at the same power, or at this at 40% lower power if you want to drop it down at the same performance level. What are your thoughts with some of the major architecture takeaways, Dave? And I'll sort of scroll through some of the visuals as you speak to them, but I wanted to get your thoughts on, let's start with efficient core and then move to performance core, maybe, or however you want to dive in.
Yeah, I mean, I think it's kind of instructive to think about those two separately, and then sort of the combination, right? Because the combination is kind of where the magic is at in some ways, right? Yeah, I guess starting at the efficient core, it's a, pretty beefy core. I mean, one of the things is I remember, we all like on our Android and any of the sort of mid-range phones these days, right, are sort of big dot little, right? With the idea being like, let's take a really small low power core and then pair it up with a bigger core. I mean, the irony is if you look at where Intel ended up, it's sort of big dot bigger, right? Like getting 4 Skylakes, that's pretty good, right? I mean, that's more performance than I'm currently packing in my present laptop, right? Which I think is I can't remember what it is, but it's like a dual core, right? Dual core, ultra mobile. So, from this standpoint, like I'm like, yeah, that's a huge upgrade. And, I think sort of the interesting thing is, you see a lot of gains from focus, right? And they're focusing on narrower vectors. So they don't have the full AVX 512 in the efficient cores. And as you pointed out, right, the cache configuration is a bit different, right? They have a shared L2 cache instead of a private L2 caches like in the big cores. And so a lot of that drives you to get a lot better area density. And then also, I think because they're not really aiming at maximum single thread performance, you can crank back some of those optimizations to sort of ultimately save power and area. And so, that to me is there we go. That's the money shot, right? So, big L1 instruction cache, big L2 cache as well. No UOP cache, for instance. They are very different architectures. And I think one of the interesting things to look at is how they might cross-pollinate over time, right? And sort of looking at that. So, there's your money shot. 80% less power. So 4x less power, sort of same performance or plus 80% performance. I mean, that's pretty impressive. And again, that's sort of the low power side, right? And so
you're looking at Skylake core here, which is obviously they're talking 2 Skylake cores versus 4 efficient cores, but you have to remember Skylake's multi-threaded. So that's really 4 threads and 4 threads compared here. Yeah.
Right. And the other thing to mention, right, as you said, so a Skylake core is about the area of 4 of those efficient cores.
Yeah.
Right. So there's a number of ways in which this is sort of an interesting, comparison, right? But I mean, so to me, it's very exciting to see these small cores finally like kind of hitting the mainstream because you rewind like 3-4 years ago, Intel had small core products, but they were essentially all Celerons and like really low end netbook type stuff, right? And so you saw this trajectory of, I think one of the phrases that comes to mind is using the right tool for the right task and really developing this breadth of toolkit to address the wide range of products that are out there. Right. And this is just one more tool in Intel's, portfolio. And now what's cool is, before, the prior generation was in base stations and Celerons and whatnot. But now we're actually seeing, okay, we have a way to add value to that mainstream notebook that we're all going to be running, a year from now. Right. And that's really exciting to me.
How do you think, and we should move on to the discussion of Golden Cove and the performance core. And Marco, I'll ask you this question as well. How do you think this plays out when you're talking about 8 efficient cores and 8 performance cores in a 24 thread configuration? Because your efficient cores are single threaded. How does it play out? Do you think it might play out versus, let's say, an AMD 16 core full fat, Zen 3 architecture? I guess it really depends how those performance cores kick in, or excuse me, those efficient cores kick in, because we can assume the performance cores are going to be very competitive with what they claimed was a 19% IPC uplift on the performance core side. Any thoughts on that? Marco, why don't we start with you?
So, I'm not sure, just stepping back for a second. those efficiency cores, back when we were first getting the Alder Lake rumors, people assumed, oh, these are Atom class, really small cores. And in terms of their physical dimensions, maybe they are, but now we know they're way more performant, way more capable, totally new architecture. So that changes the discussion moving forward now that we have these disclosures. In terms of how the mixed performance and and threading goes, I really don't know. It's going to totally be up to how Microsoft handles this. There's going to be situations where I'm sure the high performance cores are waiting for the efficiency cores. But I really don't want to speculate because I'm not certain how this is going to play out. The software is going to play nearly as big a role as the hardware.
Yeah, I would agree with that. Dave, any thoughts? I mean, and then we'll get to the Thread Director discussion, because Thread Director, by the way, and we learned a lot about it. They really went, to in depth to explain how it works. Thread Director could be a game changer. It's a hardware resource on chip, which we haven't had before, giving cues to the OS. So, what are your thoughts, Dave, with the hybrid architecture here and its competitiveness?
Yeah. So, I mean, I look at it sort of from two standpoints, right? And one is, I'll be honest, for most folks, I'm not sure multi-threaded performance is really number one. I think number one is single-threaded performance, right? And that's always been my viewpoint from the get-go, at least for the client side, right? So, like, one of the things that is exciting to me is, how many years of the Skylake microarchitecture did we have, right? And look, this is what happens when there's some misexecution on the manufacturing side. But now we've got back to this era where Intel's executing on manufacturing, they're executing on architecture. We're going to see a good, very healthy, single-threaded performance boost. So to me, that's really exciting. And then it's sort of the ability to also drive multi-threaded in a throughput way. But I think, Marco's exactly spot on, and you as well, Dave, that, the key is how do they all work together, right? Mm-hmm. And, the reality is, as you say, Lakefield was sort of a learning opportunity in many respects, in a lot of different dimensions, both on the hardware and on the software. And so I think there is a question of, okay, how well does this really work in practice? But I think one of the things to me that's really exciting is I can see a potential, very significant impact on battery life. Right. Yeah. And, I'll be honest, I don't really think for most consumers, I think 8 cores is fine. Yeah. Even 4 is probably good if they're multi-threaded. And, going beyond that is really somewhat more of a niche. So to me, to have 8 high single-threaded performance cores is great. But the thing that's exciting is, potentially the ability to extend battery life in notebooks using those small cores, right? Because they're going to have a lot lower leakage, a much nicer perf per watt profile. So, ultimately, I think there's a very real possibility. And again, as Marco said, you got to wait and see how the execution actually works out. But that this could really be a good catalyst for upgrading notebooks.
Yeah, I think it plays out real well in the notebook space. I wonder how it plays out in the desktop space when you think about heavily threaded, let's say, content creation workloads, for example. And there's certainly some accelerators on board here as well, which we, whether you talk QuickSync or any of the other accelerators that Intel has on board, that they do pretty well with VNNI for AI, all that good stuff. I wonder how it plays out versus, I mean, it's really, for what we're really looking at here is essentially a 12-core chip, in terms of threading. So 24 threads, right? 24 threads, but it's on steroids, for lack of better words. The cores are significantly more performant. So I wonder, that's the $64,000 question. I wonder what this looks like in a heavily threaded, sort of content creation, video crunching application or something like that.
Yeah.
So I just want to build on what David was just saying, how important single thread is. In terms of your experience using a PC, that single thread is basically the main differentiator. That's what you feel, that responsiveness, that snappiness. The other benefit to this new architecture is all of that fast IO hanging right off that root complex. You have, fast PCI Express connectivity right off the CPU. You have leading edge Thunderbolt, the latest wireless. And when you put all that together with really good single thread performance, that experience, especially I think in mobile, if you get that big battery boost, is going to be significant, even if they may not win every benchmark. That total package is potentially going to be very compelling, with the right drives and leading edge memory and those efficiency cores. That could spell for some really nice notebooks.
Yeah, agreed. And actually, here's the PCI Express complement that you spoke of: by 16 Gen 5 link and a by 4 Gen 4 link off the root. So hang a next gen graphics card, full bandwidth by 16 in PCI Express Gen 5, and hang an SSD, a nice NVMe SSD, and a by 4 Gen 4 link right off the root. And then, of course, you've got, what is it, another 28 lanes of Gen 4 and Gen 3 off the PCH. So really well plumbed from a serial connectivity standpoint. The other thing, what did you think about this part, Dave? 3 different fabric IO, or fabric topologies here for compute, IO, and memory. 3 independent. Again, what seems to be really well plumbed internally as well.
Yeah. And I mean, one of the things that's interesting is, I think these fabrics were to some extent in place previously, but it's sort of the degree to which Intel is sort of talking about it really externally, in which of them are new. I mean, I think one of the things that is interesting is, the big dot bigger, right? With the hybrid cores, right? We haven't seen an Intel part with a fabric, and it used to be the ring fabric, and you've now got the mesh, right? Yeah. But how that hooks up to both the big and the little, and the big and bigger cores, that's a really interesting question. But also the other thing that they talked about is, being able to optimize the operation of the fabric for latency, right? Which again, single thread performance and latency, that's really what you want as a consumer. While sort of right sizing and optimizing those other fabrics in the right way. So I think, a lot of this is about, sort of, you've got a diversity of things that you're doing and making sure you're using the right tool for the task.
Yeah. That compute fabric, 1,000 gigabyte per second, number. I think the key I took away from that was dynamic latency optimization. They're going to need to intelligently manage that fabric for whichever compute resource needs to be engaged to minimize latency, round trip latency, and letting all the different blocks talk to each other. Let's look at the performance core a little bit. Let's see, is this it? Yeah, this is the one. No, that's efficient. I'm sorry. Let me keep going. Construction control. Yeah. Okay. Here's the performance core. So wider, deeper, smarter again. Any major takeaways here? I mean, it looks like the front end and the main engine itself has been, expanded. And Intel talked about a 19% geometric mean gain across a wide range of workloads, general purpose compute workloads, so that the total aggregate average gain, it could be as much as, I think, let me scroll down. There you go. There's the chart. Could be as much as 1.6x or as little as, on the other end, in a few of these metrics. And they talk about spec CPU, SysMark, PCMark, Web Expert, Geekbench. It could be about the same, but up to 1.6. Looks like it's beefed up pretty well this year, Golden Cove. Yep. Any thoughts on any major takeaways here, like some of these different enhancements, on the front end and the out of order execution engine? Looks like a wider execution engine, deeper, smarter.
Yeah. Yeah. I mean, Marco, you want to go ahead?
You know what I was going to say is that for been doing this 20 years now, every time we have a presentation like this, it's always wider, deeper, smarter. And there's always these general terms like, improved branch prediction, where they don't give detail or things like that. I would love to hear what David thinks when he hears, statements like that where there's really no detail? What goes through your head when branch predictor?
I will, before you answer, Dave, I want to step in, and I agree with you, Marco. We hear that almost on every, architecture disclosure from both sides of the fence, by the way, Intel, AMD, whoever. But if you look at this slide, what's interesting here is they're saying how it's wider, how it's deeper. So we got 5 to 6 wider allocation, 10 to 12 wider execution ports, so allocation units, execution ports. What are your thoughts, Dave? It looks like they're saying how it's wider, deeper, smarter, at least.
Yeah. So I mean, I think one of the things you're latching onto, and actually, if you do a sort of side-by-side comparison of what they said about Golden Cove versus Gracemont, there's a lot of details they left out of Golden Cove, right? And part of that is, that's a bit more sensitive.
Yeah.
Number one. And then number two, one of the things you alluded to, Marco, is Intel doesn't like to talk about their branch predictors, not in depth, right? And this is something that is dated back for years and years and years. And part of it is that branch predictors are very much secret sauce, right? Now, there are a few things he said that were super interesting that to me had some significant meaning. And it sounds like they did actually change the branch prediction algorithm. Historically, Intel in their big cores has used derivatives of the G-share algorithm, whereas the other major style of branch predictor is a perceptron. Mm-hmm. And it sounded like, and a perceptron is a form of neural network. And so it may be that is what he was alluding to in terms of using machine learning or neural networks, right? In reality, it's not quite the same thing as the machine learning that Google is using to translate stuff or do recommendations, but it's possible they did change the actual algorithm. But the other thing that they did talk about is the size of the history arrays in the branch predictor. So you're tracking more history and able to make better predictions. But that is very much something that Intel. I have a funny story. So I was actually at an architecture conference for academics. And there's two guys, Andrei Seznek and Daniel Jimenez, who specialize in branch predictors. That's their thing. Andrei now works at Intel. Daniel, I think, is at UT Austin. But Daniel, literally sat next to me on the bus and pigeonholed me on the way to a winery for 30 minutes, trying to figure out everything I knew about Intel branch prediction. And part of that is, frankly, they are ahead of a lot of the folks in academia because their ability to characterize the applications and understand what's going on is so much greater. And that's part of why they may not want to talk about it.
Yeah.
But it is very much a linchpin, right? Because as you make the pipeline deeper and want to go faster and do more things, you need to get the branch prediction better in order to avoid wasting energy, right? And wasting work. So, I think for me, the other thing that really stands out is, if you look here, the number of loads in stores, that's one of the things that is really challenging to do is to have multiple loads in stores going, much more so than on the ALU side. And so to me, it's really cool to see that they're sort of keeping their foot on the gas in terms of widening that higher performance, higher throughput there, while keeping the latency pretty reasonable. Because this is the other challenge is a lot of times when you make things wide, your latency stinks, right? And this is the story of a GPU, right? A GPU is to a certain extent what happens when an architect says, I don't care about latency much anymore, but let's maximize throughput, right? Yeah. This is a little hyperbolic, but for Intel, single thread performance, low latency has always been sort of the a central value proposition. So yeah, it was kind of cool to get some details on that and how they'd improve things there.
You're right, though. I actually wrote this section of our coverage at Hot Hardware, and that's these are all good points. They keep some of this close to the vest, and I must admit, as we were burning the midnight oil, Marco and I tag teamed this absolute novel of an article because of so much that was disclosed. I was thankful that I got to this point, and I only had a little bit of slideware that said what they tweaked in the architecture a little bit, and then it was okay. Here's our performance claims. Here's how it's better. but we're not telling you much more.
Yeah.
You know, the 3 bullets here, that was kind of it, you know, but then, you know, you get a little bit of meat here, and, you know, yeah, you got to keep some secret sauce because, you know, competitors are watching.
Yeah. The other thing I'd say is the length decoding from 16-bit to 32 bytes. Sorry, 16 bytes to 32 bytes.
Okay.
That's actually been a limitation for a long time in Intel processors. So, you know, maybe even a decade or so, like going back to like Marome or something. So, you know, that's a significant thing to change, and probably opens up a much wider playing field for future generations.
Yeah. Yeah.
Can I interrupt quickly with a question from?
Yeah. Go for it. I haven't been monitoring that.
We have the Tech Potato Ian Cuttress with a question.
Oh, there we go. We couldn't
the doctor.
If only he was on a reasonable time zone instead of being in our former colonial overlords.
Exactly.
So he wants us to ask David what he thinks about the applications that drop in IPC with the new performance core. Any thoughts on why there'd be a performance drop?
Yeah, interesting. So right here, and we don't know exactly what those applications are because they list, let me just make sure I can read this. Spec CPU 2017, SysMark 25, that's Crossmark. PC Mark 10's in there, Web Expert, and Geekbench. I'm not seeing Crossmark. I think that's what I see. Anyways, any thoughts on that? Yeah, it does look like it drops below the 1X line, right?
Yeah. I'm trying to draw with my mouse. I'm probably not. It looks like there's 3 applications that lost some IPC.
Yeah, like
right
there. Yep.
Yeah. And so, I mean, it is an interesting question. Also, what is the baseline? Right. I mean, one question is whether any of those are using AVX 512, right? Because certainly in Alder Lake, as they said, there is no AVX 512 to have smooth hybrid handoff to the little cores. The other sort of question, I mean, it could be that those are also, you know, they talked about widening up sort of the interface to the L2 and some things in there. It's possible that the L2 latency got a bit higher, and you might see a bit of an impact there on a couple of pathological cases.
Yeah.
That would be my guess to look around, but I mean, it would help if they told us exactly what those 3 bars that dropped were. And then, you know, the other thing is also, I don't know if we actually have enough detail about Golden Cove to identify the exact ways in which you might lose performance. But again, my intuition is, you know, maybe you had something where the latency just bumped up a little bit in order to go deeper and wider. And, you know, you just happen to be banging on that one bottleneck on a couple of these workloads. But
yeah, I'm drawing this line across here. So it looks like if we go over another notch, the 1.1x line is right. I don't know if you can see my cursor on the screen, is right about there too. So there's, you know, a half a dozen that are less than 10% gain, and then those 3 that are sub 1x.
Yeah.
And then everything else, I mean, obviously there's a bunch that are way up there at 1.5, 1.4, 1.6.
Yeah. And also, right, this is ISO frequency, right? And And so the interesting question is, especially with all the dynamic clocking and everything, is if you look at those pathological workloads, like what frequency are they running at? Like, you know, we know that this process is going to be faster than the prior one. And, you know, it's sort of, I think that was, you know, going back to the manufacturing day, you know, I think my friend Sanjay was like, you know, we're doing 4 or 5 process nodes in like 4 years. Like, this is an incredible cadence. Like, you know, everyone is rowing like 6 or 7 days a week. And so, you know, if you're getting 10, 15% higher clock frequency, you know, in general, you know, it certainly makes up for that. But then there's the question of what do you actually get for those specific workloads too, just to really dial in.
Yeah.
Just for the potentially maybe the less technical folks that may be seeing that and saying, oh, this thing's only 19% faster. That's geometric mean at ISO frequency. These new chips, they're potentially going to switch states faster. They, you know, they are going to potentially run at higher clocks. So absolute performance may or may not be significantly more than that, but that's just something to consider.
Yeah. As well. I mean, my intuition is, you know, you could see the process giving you another 15%. So, you know, that geo mean, and again, that process being faster is also somewhat of an average. So, you could put those together and be like, yeah, 35%, like that's a pretty solid number.
Yeah, and I think we need to maybe explain to maybe some of the less technical folks in the audience as well. ISO frequency, similar clock speeds at the same clock speed. Yes, and so what you're saying, Dave, is that enhanced 10 nanometer superfan could also bring the performance core or the efficiency core a clock speed headroom to scale north of 5 gigahertz or whatever it might be.
Yeah, that's right.
So
and that ISO frequency was only 3.3 gigahertz for that example. So who knows what that does to the fabrics? There's so many variables. Intel is very strategic with every slide. So what we were showing there is exactly what they wanted to show us and nothing more.
And
yeah,
can we also say that generally speaking, Intel is conservative with their claims when they're not making comparisons versus other architectures versus a competitor? They're generally pretty conservative. Is that fair? Would you agree with that, or is that not fair?
Yeah,
depends who's presenting.
Yeah. I mean,
the CPU guys, I think.
So one of the things that I like about Intel's historic benchmark presentations is that they show you the S curve, right? And reality is performance is not a single number.
Yeah.
And so, there's a full spectrum of things where you get fantastic performance, somewhere not a big improvement. But I think really accurately portraying that, to me, is higher credibility than, relying on a single number.
Right. Yeah.
Especially if that number is Cinebench.
Exactly.
I mean, and it's just, again,
like AMD's poster child benchmark, right?
Yeah, no. And I mean, again, this is not to pick on AMD, but if you pick any one number, that's only as good as it generalizes to your situation. And if that's what you run all day, then that's actually the best number. Yeah. Right. But if it's a creativity benchmark and you're gaming, or it's a gaming benchmark and you're really big into like compiling code, and that's why it's nice to get a broad range and look across the spectrum of workloads.
Yeah, which is what Intel did. So kudos to them for laying that out. We don't know exactly what it is, but they laid it out and showed the curve. So, anyways, hey, we should probably move on because we're running out of time. I
was just going to ask. Let me ask two quick. Dave, how long do we have you? I know we're going to wrap up quick, but
I can go a little bit longer. I'd probably have to bounce at 2:15 my time, so 5:15 yours. So we can get in. Do you get to throw in extra ads this way if we do it?
I don't know about that.
So we're supposed to have a special guest next week. Is that happening, Dave?
We may be having a special guest from the Intel graphics team, believe it or not.
Should we cruise through ARC because that guest might cover that next week and get to the crazy stuff on Vecchio?
Yeah, we should probably cruise a little bit through ARC. I think that's happening. And then I also want to mention real quickly Thread Director. Anything there, Dave, before we move on from Alder Lake? I think Thread Director is an interesting thing. Anything jump out for you with that, or is it hey, let's see how it works? It's a novel concept.
So, the way I look at it is, first of all, in terms of talking about the things that they exposed to Thread Director, that's pretty exciting. A lot of those sort of performance counter level things were not previously ever exposed. So I think it's cool to see that there's more information being made available to the thing that schedules.
Right.
Right. But yeah, I mean, I think in practice it is like, how does it really work in the wild? And the nice thing is, we've got a decade of previous experience with Big.Little in the context of the Android ecosystem.
Yep.
Right. And so, I think there's an opportunity to capitalize on learnings from there, but I'm sure there's going to be a learning curve for Intel and Microsoft as well. But I'm really excited to see what it can do.
Yeah. It's cool. It's cool sounding technology for sure. And I'm eager to see what it does as well. So, and by the way, I did confirm with Intel that in Lakefield, there was a hardware resource. They didn't call it Thread Director, but there was a hardware resource for thread management to work with Windows 11, which is why we did see a slight performance uplift. Ben Funk on our team actually took Lakefield and compared it versus Windows 10 on Windows 11. And there was a slight IPC uplift, slight performance uplift in general for Lakefield. So yeah, interesting that they were definitely, as you nailed it, Dave. I think it was a learning experience. Lakefield was a learning experience for them on a smaller scale. And here we are on the bigger scale with Alder Lake. So good stuff. All right, let's talk about Xe Core and the building blocks of Xe HPG. And Intel Arc, which is the GPU core architecture branding now, or I should say really code name. And then, Arc is the product branding. Alchemist is the GPU code name. So there's the Xe core block. This is a single compute block and 16 vector engines, 16 matrix engines. They build these into a slice, and there are 8 slices per GPU. And if you do the math, full fat, what we did discover, which was being rumored for a long time, what we did discover was that Alchemist in its full fat implementation, the biggest Alchemist is going to be a 512 vector engine or core, for lack of better words, GPU. So we have the math now. 16 vector engines. There's 4 of these cores per slice, and then 8 slices per GPU, if I have that right. Just doing the math. Anyways, thoughts about this real quick. I think, we didn't get a lot. We're just getting, a certain tease here. XeSS is their super sampling algorithm that they came out with as well. It's great to see that. What were your high level takeaways here, Dave?
Yeah, I mean, so I think the interesting thing to me was you have a big improvement in getting the matrix engine in there, right? In treating matrices as a first class, computing primitive. And then the XeSS is also, and ray tracing, right? I mean, if you look at like the advances that Intel has packed in, like that's a pretty big improvement in the graphics architecture. And
Sorry, scrolling down. Go ahead.
Yeah, no. I mean, I think overall it's quite impressive. I mean, we will have to see ultimately how it does at a product level, because while it's true that Intel had a very effective GPU, scaling it up, you tend to run into bottlenecks, and then you find them, you hammer them down. But I mean, this certainly sounds like pretty good to me, and XeSS looked quite good. Right.
Yeah.
I happen to be quite fond of, I have a bit of a background in ML, and it's nice to see that being used in a productive way, and it kind of looks, generally on par with, NVIDIA's sort of second gen DLSS.
Yeah.
Which is nice. I think the first generation DLSS was, certainly, first of all, it was done by friends of mine. So it was, big step forward. And, but, it did suffer from some image quality problems in some scenarios. Second gen really kind of cleaned it up. And so it looks to me like Intel generally landed at about sort of the second gen sort of capabilities.
Yeah, I would agree. I'm just going to scroll back real quick. This is an interesting slide right here. It's kind of hard to see. I could blow it up a little bit more, but you're seeing the grid. This is your 8 slice, 4 cores per slice, or 4 arrays per slice, really, we should say. And then if you went down to those little gray blocks and all the cores, you can see those are the 16 matrix engines, or do I have that right? Yeah. Vector engines. And then the yellow horizontal bars down the bottom, those are your RT cores at the bottom of each array. So there's 4 RT cores per slice. And if we did a full 512 Alchemist implementation, you're talking about 32 RT cores. So compare that to like an RTX 3070 at 46 RT cores. I did this math last night, or a 3060 at 28. You're somewhere in the middle between a 3060 and a 3070 in terms of RT core complement. RT cores may not be created equal, of course, but that's kind of what it's, plumbed with.
Yeah. No, I think that's right.
Yep. And but it's interesting stuff. And then XeSS I thought looked pretty sharp as well. The demo they did looked great on Unreal Engine. So
yeah, well, we don't know the resolutions. So
right,
you can't draw too many conclusions.
Image quality though looked good.
Right, it struck me as sort of it lands in between DLSS and FSR because Intel has hardware acceleration with their GPUs, but it will run on competitive GPUs as well, as long as it. What's the name of the instruction? DP4A.
DP4A. Yep.
Yeah.
So that's an interesting take too, and the speed up, while not quite as good as Intel's own hardware, is still really good.
Yeah, it's right there.
This is going to be interesting to see if it gets adopted by game devs.
There's the speed up. You can see the top bar. And by the way, this is a sneaky slide. I told Intel that the top bar is native 4K. Okay, so that's the native 4K, performance bar, which is longer. Shorter is better. And then XeSS, and then XeSS with DP4A below it. So XeSS with an XMX, which is the hardware resource on Alchemist that handles the an XMX engine that handles XeSS. You can see it's obviously faster, the fastest, the shortest bar. But with DP4A, which is a standard machine learning, Dave, you can probably talk to that a little bit better than we can. And it runs across, we think RDNA 2 with AMD, and then certainly NVIDIA with, CUDA support for DP4A. It's slightly slower, but they're saying image quality is the same, just, performance, the scales, accordingly. Thoughts on that? I found the DP4A fallback was an interesting. I thought it was great, that they brought that into the mix as well.
Yeah, I mean, so the DP4A, that's just a dot product instruction as opposed to a full matrix multiplication accelerator like XMX or what does NVIDIA call theirs? The Tensor cores. Yeah,
Tensor cores. Yeah.
Yeah, all the marketing stuff is starting to fall out of my ears from time to time now. I think that happens when you get older, but no. I mean, I think it's nice to have that fallback, especially maybe for prior generations or whatnot. But I think this is one of those ways where as you're seeing the industry move towards doing a lot more machine learning, you can actually use that for some of the most common applications out there, which is really, really fantastic.
Yes. KW are exactly right. There you go.
100% hit it on the nose.
and there's the bar to show it right there. So yeah, absolutely. So good stuff for sure. All right. So are we going? Yes, we should move on to the big iron, right? You want to talk?
Let's just get a quick yes or no answer from David on one quick question.
Okay.
David, is Intel going to succeed with GPUs this time around?
Oh, that's a good question.
That's not a yes or no question.
No, your gut, yes or no? Is this it? Do we have 3 competitors come next year?
Yeah.
Yeah. Okay, good. I think so.
I mean, I think the thing is, right, it's as with many things, it's a long haul, right? Like, if you look at sort of where Intel is with respect to graphics, I think on a lot of the graphics architecture stuff, they're sort of ahead of AMD, behind NVIDIA. But, AMD has been doing high-end GPUs for well over, like 2-3 decades, right? And so, it's sort of, you have to look at what each player is trying to improve to really catch up, and, the teams they have and the resources they have. I mean, to me, one of the really exciting things, and this is, Dave, I'm going to segue into the big iron here.
Yeah, baby.
Right. So you can slip me the $20 bill a little bit later, but is Intel really has the ability to throw down their super advanced packaging, heterogeneous process integration, right? And more so than any other company, like they're actually getting around to doing it, right? Lakefield was already shipping not a huge number of units, but like Lakefield was heterogeneous 3D integrated silicon. Like that's pretty cool.
Yeah.
And by the way, Lakefield is like, 2 pieces of silicon, and then like Ponte Vecchio is 47. That's sort of like someone wrote you a blank check and is like, all right, guys, like I want you to get all the extra credit on this homework assignment.
So I wrote
Great
the Ponte
analogy.
Vecchio. I wrote the Ponte Vecchio section of our piece, and as I'm writing it, I can't believe that thing got approved. Like that was
Oh, it's
such
a
an ambitious
freaking
project.
beast.
It's
Yep.
like someone had to be pummeling, the higher ups to get that thing. Yeah, go ahead, make it. Go make that thing. Sure.
Department of Energy.
Exactly.
No, I mean,
the
I'm
size
serious,
of
but
it.
yeah, I mean, like it's super cool, right? And I mean, to me, and this is what I've said to some other folks, is to me, Ponte Vecchio is sort of like the platonic ideal of silicon integration, right? And the question is, right, you know that dense logic, right, like you want for a GPU, high speed logic like you want for a CPU, those are different animals.
Yeah.
SRAM is different, right? Dave, you know that from selling SRAMs way back in the day.
Yep.
Right? Your base die is different. Your memory is different. Your SerDes are different, right? All of those things naturally want to be different. And so, getting the ability to piece it all together, right, really kind of frees up your designers, your architects to really properly optimize. And so to me, it's really cool to see how this is going to go. And, Ponte Vecchio is not a product that I'll probably ever buy. Maybe they'll sample one to me. Hint, hint, Raja. But like what's exciting is to think about, let's take those same building blocks and let's see what we can do for a high-end desktop chip. Let's see what we can do for a server chip. How can we take something that, Ponte Vecchio is probably going to be, thousands of dollars probably, but what can we do to bring that into the mainstream? Because that's sort of exciting and a preview of where we might be headed in 5 years.
Yeah. Yeah. I think you hit the nail on the head when you talked about Intel being the manufacturing juggernaut that they are. That is what's exciting if we click back real quickly to the GPU space. And certainly it applies to Ponte Vecchio as it's a big chunk of its GPU. They are the absolute manufacturing machine. They always have been, and it's going to be interesting to see what they bring to the gaming GPU space when they get that product to market. You may find that supply is suddenly a little bit more loose and liquid than it is from the other guys. They have a way of go to market that's unbelievable.
Well, hold on. In all fairness, right, they're using TSMC for some of their silicon as well. So,
Yep.
I mean, but when I look at it, like here's a good.
I was thinking packaging, and I mean, that's no joke.
Yeah, the packaging is super unique, and I mean, if you think about it, like the thing that was interesting in like, so you have the Rambo cache here, right? It's a separate cache chip that's 3D integrated, right? To me, and we were just talking about the Radeon 6600, right? Where Marco, you pointed out, like one of the high level trade-offs AMD made was, hey, we're going to use a narrower memory interface, but we're going to glom on a huge amount of cache, right? And that cache is probably a third of the area of the GPU. Well, in sort of an ideal world, you might stack that guy on top vertically and use a specialized process just for cache, right? To cost optimize and balance everything, right? So to me, that's kind of the promise. If you think about Ponte Vecchio flexing muscles, like once you flex those muscles, learned how to do it, learned how to scale into high volume, like that to me is the promise of what we can see in the future.
I'm trying to find the slide that speaks most prominently to you, Dave. Is this it for Ponte Vecchio?
No.
It's further down, the one that shows all the different tiles.
Keep
Keep going, right there.
Yeah, there we go.
There's
the
right.
Yeah, it's so much is going on there.
Oh yeah.
Right? And then the other thing is, right, it's also like, this is the other thing that it's easy to neglect. And like, I will be fair, like my first 10 years of really watching the industry, I didn't pay that much attention to manufacturing and like the physicality of what is going on. But like, one of the issues that you get with something like that is you have all this silicon stuffed in a package. And by the way, that stuff, when it is all heated up, the silicon expands at one rate, the packaging expands at another. Like, there's so many things you have to worry about. And it's like, oh yeah, actually you're kind of limited because you don't want these things to crack. I hear that's bad, right? And like, so there's just so many things that you have to handle to make this go, and that physicality is very challenging, and that's something I've come to appreciate, much more in like, the last 5 years, is just, when you think about having, how many transistors did they say are on this?
Greater than 100 billion.
Yeah,
100
right.
billion.
Right. So the thing is, right, every one of those transistors is connected up to wires.
Yeah.
Now, not every single one of those wires needs to be perfect, right? Because they've
Yeah.
always got a little bit of redundancy, but like 99% of them have to be. And that's like amazing when you step back and think about it. It's just like, boom, we're making these microscopic wires, nanoscale wires, and they just work all the time.
Agreed. And you look at this, you've got 1, 2, 3, 4, 8, 9 different levels of tiling. So compute, Rambo, Foveros, space tile, HP. I mean, it is a stacked, like, when you think of the term stacked, this is stacked.
Yeah,
and
literally and figuratively.
Intel talked about, just a few weeks ago, all of the different advances in manufacturing and packaging.
Yeah.
And you can understand, this thing powered up earlier in the year already. So like they've had this for a while already.
Yeah.
So it's really impressive. While they may have struggled at the transistor level for a few years, in terms of packaging and other innovations, this is a wow product. As I'm learning more about Ponte Vecchio, I'm just shocked that they built this thing and it works. It's amazing.
Yeah.
Let's talk about amazing processor, right? Here's the bring up A0 silicon throughput, currently, and it's going to get better because A0 is real early in the game. What are the applications for this that you see? Is it machine learning training? It's HPC, big data analytics? Where do you see this thing really making a market impact, Dave?
Yeah, I mean, I think you nailed it, right? Like, so the primary customer for this is Argonne National Labs, right, which is run by my alma mater, and that's a big HPC site. And so, also you can do machine learning on this. I think, one of the challenges about HPC and machine learning at HPC, there's sort of a default assumption that you have a lot of graduate students, so you can rewrite your code and you'll tune your code for it. I think one of the big challenges with machine learning is the software stack that is required to really get customers is huge, right? And it's not that you can't get there, but the default expectation is, your customers are going to run TensorFlow or PyTorch, and they just expect it to work out of the box, right? Like, so that's a very heavy lift to get all that stuff up and running. So I think, HPC is absolutely, the low-hanging fruit, the easiest one to approach. But this could, if you look at the matrix units, those are handling bfloat 16, which is great for a lot of machine learning. It handles FP16, which is oftentimes good for vision applications of machine learning. Mm-hmm. So I think it could potentially be enabled there. But again, that's really a software question.
Yeah, and this is, I mean, to me, this whole project, the whole Ponte Vecchio project is, in addition to it being, I mean, it's a high margin, hard to produce, high margin probably type product, but it's also like put a stake in the sand on high and say, hey, look at this, beat this. I think for Intel. What do you think, Dave? Is there a little bit of maybe chest thumping that went into this project? And they call it a moonshot, and I think they were looking at just hey, okay, we're going to flex the muscles, as you said, right?
Yeah. The other thing to keep in mind here is this is also the first time doing all of this stuff. And like, there's like one of the things that I think is really, really impressive is, Intel's not a company that's known for short development times. And this was done on a super short development time. Yeah. So, plus all the like new technologies. So in some ways, it wouldn't necessarily, I mean, I think part of the point of this is, packing down the snow, right? If you think of like climbing up a mountain to smooth down the path for later generations as well. So, because, I'm sure, you come out at something like this and you're like, wow, there's like, anytime you do anything, there's always like a dozen things where you're like, should have done that one different. Well, we'll fix it next generation, right? So, and I am sure, given just the amount of complexity and novelty, like Intel has learned a huge amount.
Yep, agreed. Anything on Sapphire Rapids that jumps out to you? And we should probably wrap because we're running short on time, but I'll share this out as well. Let's see. Go to the architecture. I mean, we've got these new instructions for machine learning. Yep. I think that's near and dear to your heart. You get an 8x uplift in int 8 performance, which is inference.
Yep.
Here's the block. This is performance core for all intents and purposes.
Yep.
So Golden Cove core architecture, exclusive across chips that go, what is it, up to 56 cores?
I don't think they said, but
that's what the leaks say.
Yeah, the leaks, right?
Yeah.
Thank you.
I am very curious. So I did a bunch of projections back in 2015 or maybe even earlier on what Sapphire Rapids would look like. And so I'm very curious to see how that lines up to reality. But, to me, I think that the big thing here is, this is the first time that EMIB's going into high volume production, right? And this is, again, getting back to the physicality, right? Sapphire Rapids is the product that is, it doesn't earn all of the data center group's revenue, but it's the vast majority of it. So this is saying EMIB is ready, high yielding, and good to go, and
volume,
full faith and confidence in it. So to me, that's very exciting because, then the next step is clearly going to be on the client side. And by the way, I'd love to get a Sapphire Rapids with HBM sampled too. That'd be pretty sweet. But no, I mean, it's interesting to see how it's architected. But and the other thing that I thought was like very interesting to me, and somewhat underappreciated because it's hard to quantify, but Sailesh made a really good point, which is that when you're architecting for the data center, a lot of your customers, you think about like an Amazon, they don't care about a server. They don't care about 10 servers. They don't care about 100 servers. They care about 100,000 or 1 million servers.
Right.
And so it's sort of interesting to think about the things that you put in to a design to optimize for that use case, because it's in fact very hard to study because, most people are just not running at that scale. And, some of the things that you're going to want there, may not really show up for sort of, in a 1 node or 2 node or 3 node configuration. But I think a lot of those features are pretty cool. They talked about quality of service stuff, right? So making sure that, one VM doesn't choke off the other for access to memory or IO or whatever it is. So I think that's pretty cool. And then, again, seeing, the other thing here is, so that's exciting. And, Sapphire Rapids is probably a more tangible product to most of the audience, right? We know that historically Intel's high-end desktop uses a cut-down Xeon. So, we may actually be able to get Sapphire Rapids in our hands.
So Dave, scroll down to that to show the configurations for a second.
Right.
If anybody from
right there.
Intel, right there. If anybody from Intel is watching, Dave and I want the configuration on the right. Ian doesn't need more than one. So one can go to Dave and one can come here.
It's it. There you go.
Yeah.
And we'll test them with love. Absolutely.
Yeah.
Interesting question from James Pryor. Dave, do you care if ML instructions are proprietary or open? And let's go back to this jammy right here.
Yeah.
I guess.
So I think the reality is that when it comes to machine learning, like I said, up here you have your TensorFlow and PyTorch, which are sort of high-level frameworks. You can think about that as conceptually like the Excel of machine learning, right?
Mm-hmm.
It's kind of at the Python level. In reality, it's up to the vendors to provide all the glue that connects that to their hardware. And so that means the vendors have to provide, your matrix multiplication kernels, your math libraries, your compilers, and all of that. So in reality for ML, and, a lot of that stuff tends to be hidden. I think the fact that Intel is running with their own instruction set, that's totally fine. In reality, you probably will, you will ultimately see other folks doing different kinds of matrix multiplication primitives in there. But, I don't think it's really a significant barrier, right? Certainly, if you look at NVIDIA's GPUs,
oh yeah,
CUDA is, proprietary to NVIDIA, and that hasn't stopped them from, having a phenomenal business and a phenomenal impact in the world of machine learning. Yeah. So I don't think that's a barrier. But, I think the value of openness is in building that software ecosystem, right? And getting everyone to potentially contribute to it and see how that, sort of turns out ultimately.
And the potential is good for Intel to do that with these new instructions. Frankly, versus NVIDIA back in the day, which, they had to go Johnny Appleseed, and basically, fortunately they had an install base of, academia, kids in college that were probably gaming on their GPUs and then, doing some machine learning on their GPUs as well, dual purpose. And so it worked well for them. They could sort of seed the academia with it to get CUDA out there in the open for machine learning. But yeah, interesting stuff. It'll be fun to watch.
Yeah.
Yep. So I think we probably got a wrap, right? Because you're running out of time, we're running out of time, and we've covered just about all the high notes.
And I think, Dave, you might be running out of beer.
I'm definitely running out of beer. Let me put this back because I'm already, and that's one's enough, because if I'm doing the knobs and dials, I'll only screw them up more the more beer I have. So
thank goodness it's not heavy equipment.
That's it. We're not driving anything right now. So
before we close, I want James Pryor to see a box that showed up.
Look there you go.
Oh, very cool.
That showed up today. We got to figure out something fun to do with that.
Oh, yeah. Little single board computer based on sci-fi technology kind of thing.
There you go.
Oh, beautiful.
Fantastic.
Well, James, we'll see if we can put it through the ringer here. But anyways, David, thank you so much for joining us today. It was a pleasure.
Yeah, it was super fun. Thanks for having me on. This was great.
Yeah, and it was great to pick your brain and get your opinion on all things Intel Arc Day. We look forward to having you on again the next time we have something deep and technical to chew on, because I don't know, you seem to have a pretty good digestive system, I guess.
What can I say? I've been working on it for years.
Good stuff. David Kanter from Real World Insights. Thanks for joining us. You can find us on the web at hothardware.com, twitter.com/hothardware, youtube.com/hothardwarevids. Hit thumbs up, subscribe, please, and you'll get notified when we go live. Try and go live every Wednesday. We changed it up this week. Usually Wednesdays at 5:30. Changed it up this week because of Intel Architecture Day, so that we could chat through all this stuff. Have a contest going on right now, giveaway, right, Marco?
Absolutely. I think we're in the final days. Stop by Hot Hardware. Really easy to enter. Like a couple of social media pages, and you will be entered to win an awesome Alienware Aurora rig sponsored by Asetek.
I am dropping a link in the chat. Yes, the good folks at Asetek and Dell Alienware have put up a beastly machine based on Intel 11th gen core technology, as well as an RTX 3080 under the hood. It is decked out. It's beautiful. Hit the link there, and you can potentially get in it to win it. And with that, we will bid you adieu. Check us out at hothardware.com. Thanks so much for stopping by. All right.
And broadcast.
I am trying. Hang on.